Hello, we're the Silicon Slabbers and we'd like to introduce ourselves. This is Vanshika, Nishant, Casey, Steven, and I'm Josiah. We're working with Telefirma to develop an automated slab lifting system that will drastically reduce the time and cost that currently is required to lift a given slab. Currently, Telefirma's manual process requires a half dozen men and will take an entire day. Our system is hoping to reduce that drastically, allowing it to be able to be done but with only 2 people in under 2 hours.
So our first concern was the sensors and how we should measure the slab elevation. So we researched into several different sensors and picked the top 3 based on the cost, accuracy, and the feasibility of it. And the top 3 were ultrasonic, optical, and accelerometers, which you can see in the graph here. So accelerometers were way too inaccurate given the double integration. Optical were prohibitively expensive given our budget, so our best option was ultrasonic, which has a 3mm resolution and a really cheap price tag.
Our second concern was choosing a microcontroller, which collects all the data from the sensors while seamlessly communicating back the data to our central hub. So as you can see, the M is the Arduino, which we're going with the Arduino Mega 2560 Rev 3 for 3 reasons. The first one is that it's because Arduino is an open source computing platform, we can get readily available libraries which will help us code. Second, it is easily interfaceable with our choice of sensors and our choice of central hub. And last, because the Mega has 54 digital I/O pins and 16 analog pins, it can accommodate 10 sensors and 10 valves per Arduino.
So for our central hub, we use Raspberry Pi 3 Model B Plus because it is cost efficient, it has cloud capability, and it's portable. As you can see, we have a 30-pair system in which we have 3 Arduinos connected to the central hub, and every Arduino is connected to 10 sensors and 10 valves. So there's data communication between the sensor and the Arduino.
Next, we consider communication between each element in our system. For the communication from the on-slab Arduinos to their sensors, we're going with a digital trigger echo system that we believe will have minimal voltage drop, even across longer transmission lines. The communication with those Arduinos and the hydraulic valves, we're still coordinating with the mechanical team designing that hydraulic system. And finally, with communicating between the hub and the on-slab Arduinos, we'll be using the serial RS485 communication protocol.
The graphical user interface for our system is a web application, and this is how the user will control the lift. There's a start and stop function, as you can see in that diagram, as well as input fields such as number of reference points and desired lift height. On the right-hand side, you can see there will be a slab display showing the elevations of each pier, as well as using color coordination to show any deviation with the surrounding piers. All of this data will be uploaded to Google Cloud Platform by the hub, where a server is hosted and managed by Google.
We're the Silicon Slabbers. Thanks for lending us your time, and we hope you come by our table. We're team number 784. As you can see, we have a little prototype here, and we'd love to talk to you about it. We'll see you at our table. I'll open up to questions.
Yeah, I didn't get, is this, like, when you adjust these slabs, does somebody have to manually adjust them, or is there so you got a guy watching a screen telling his local guy, hey, you need to adjust slab 6 or whatever?
So the current method actually is just completely manual, and that's what we're trying to move away from. The current method, there are a team of workers at the slab, and they are literally tightening screws to lift the slab, going in like a wave back and across to lift each pier. What we're trying to implement is a hydraulic system. So a foreman at the slab will set up all the hydraulic jacks, be able to operate it all from his device. All the controlling and feedback loops will all be done at the hub, and those will control, they'll gather the sensor information and control the valves.
And how they're measuring it right now is based on a pipe with just tape, so they're just checking it every once in a while.
So when you measure, you lift it up with a hydraulic jack, and then does that hydraulic jack eventually get removed, and you've got like a metal post there, or how does that?
Yeah, so there will be a protective void held up by like a metal post. The mechanical team is all designing that, and we don't have our hands in that very much, but that's exactly right.
Yeah, we're mainly focused on the sensor system and like the web application.
Okay.
Guys, I like this a little bit more visual, actually, because like the slab, this is all, diagrammatic. So actually, they're kind of like a visual, because that's the same thing we kind of got lost in. How does this really work? So, and just for the next time to think about
Thank
that.
you. Thank you.
So what's not clear to me is what the cost is compared to the existing solution. You mentioned that, hey, it takes more people a whole day to do it, so there's value in the time, but we're also talking about dramatically increasing the complexity of the lifting mechanism.
Mhm.
So have you factored that in? I mean, are we really addressing the biggest expense, or is this simply a matter of getting it done faster?
The main benefit cost-wise would definitely be that this system could be reused repeatedly. So after over only like a dozen or so uses, it would pay for itself with the same amount of cost that would be required to have the entire crew out there. But yeah, it's one huge benefit is the amount of time that it takes. That can also really make it possible for multiple lifts to be done each day.
Yeah, that should be part of your follow-up presentation. You know, you say it's a dozen times or whatever to pay out. You should have some kind of data or something
Yeah,
for
that's
that. Yeah.
definitely what
Yeah.
our goals for next semester are.
Okay.
Hash out those costs and figure out exactly where we're going to
Okay.
make up that money.
Thank you very much.